Okay, welcome back to AP Calc AB videos, and actually sorry for not mentioning this at the end of the previous one, but before we move on to any theorems, we're going to have to figure out how to solve some special types of limits. So there are three ways that you'll learn to solve a limit during calculus: plugging it in, factoring it, and rationalizing it. So these are the three most basic ways. You'll learn some more advanced ways of solving later on, but for the limits unit of your class, these are the three that you should be learning. Now, you only use factoring and rationalization when your limit is in indeterminate form. Well, what is an indeterminate form? Let's say you wanted to find the limit as x approaches, maybe we'll go with x minus 5 over 2x minus 10 as x approaches 5. Well, if you just try plugging in 5, what do you get? 5 minus 5 is 0, 2 times 5 is 10, 10 minus 10 is also 0. Well, how do you solve a limit like this when it's 0 over 0? You know, we haven't learned that yet, right? So this is actually known as indeterminate form. Now, there are various forms that are similar to this, such as, infinity to the power of infinity, 0 to the power of infinity, 0 divided by infinity, infinity times 0, and such forms. So whenever you end up in a form like this, that is known as an indeterminate form because you can't give it a numerical value, especially. Now keep in mind, it's very important that a value like 5 divided by 0 is not indeterminate. This just approaches some incredibly large value which you quantify to be infinity. So this, whenever you see a value like this, do not use factoring and rationalizing to try to simplify that limit, because that will get you a wrong answer. So we'll start off by going over these three methods. Well, the first one, plug it in, we'll just call that P. That's our most basic limit form, or limit solving form. So if you have a limit as x approaches c of some function, you just plug that c value in and you get f of c. So what's an example of this? Let's say you have the limit as x approaches 2 of 5x minus 7. Now you just plug in 2 for x and you get 5 times 2 is 10, 10 minus 7 is 3. So that's very, very basic. That's plugging it in. But in the case of an indeterminate, we could do things like factoring or rationalizing. Now let's say we have a limit as x approaches 0 of, we'll go with x squared plus, let's say 5x plus 4, x squared plus 5x plus 4, and then x squared plus 6x plus 8. Sorry, not as x approaches 0, but what is the value of this limit as x approaches 4? Now let's try plugging this in. Well, what will we get? Sorry, negative 4, not positive 4, as x approaches negative 4. Well, negative 4 squared is going to be equal to 16, and then a minus 20 plus 4 over 16, then minus 24 plus 8. And if you do the math, you're going to get 0 over 0, which is indeterminate. So this does not give us a specific value. How do we solve something like this? Well, if you look at these polynomials that you have, you'll notice that you can factor them. So if we were to factor these, doing the FOIL thing you learned way back in probably Algebra 1, maybe even Algebra 2, where you're going to get x plus 4 times x plus 1 over x plus 4 times x plus 2. Now you have a common factor here. You can take out the x plus 4's completely by just dividing it out, and this becomes your new kind of f of x. Now notice that when you plug in negative 4 here, you don't get an indeterminate form. You're going to get negative 4 plus 1 divided by negative 4 plus 2, which has a numerical answer, which is going to be negative 5 over negative 6, or just 5/6. So that is going to be the answer to your limit. More specifically, the limit as x approaches negative 4 of this function is going to be equal to 5/6. Now that's, once again, keep in mind you have to do this step. You have to list out that that function is indeterminate at that value. Now we'll go a little bit in depth into rationalization. We don't have much space here, But if we want to talk about a limit where we use rationalization, so maybe limit as x approaches, we'll determine the value in just a second. So what if we have square root of x minus 2 over, we'll go with x approaches 4, obviously. X approaches 4 over square root of x minus 2, and we'll go square root of x, let's go 5 square root of x, which minus 10. Now, if you plug in 4, obviously you should get 0 over 0, which is indeterminate. But you'll notice that since these aren't polynomials and can't be factored, you can't use rationalization. So, rationalization. And then, factoring here. You can't use factoring. You're going to have to rationalize that function. How do you rationalize? Well, you find that common denominator. So we'll multiply both sides of this function, the top and the bottom, by 5 root x plus 10. 5 root x plus 10 and 5 root x plus 10. So when you multiply this out, you should have a common denominator or common factor that you can actually cancel out. So doing the multiplication, you're going to get 25x, and then you should have minus 100. So 25x minus 100. Okay, well, over here you're going to get 5x. So you're going to get 5x. Now plus 10 root x, minus 10 root x, which cancels out, and then minus 20. So you can, once again, you can use your factoring method once you get to this step. But to get to here, you have to rationalize your function, which is what this method is all about. So we'll factor out a 5, and you get 5 times x minus 4 over, cancel out a 25 over here, 25 times x minus 4. Now x minus 4's cancel out, and you get 1/5. Whoops, 1/5. So what is the limit as x approaches 4 of this function? That is going to be 1/5. So these are 3 of the most basic ways you'll learn to evaluate limits. Now that we've learned a little bit about indeterminate form and how to evaluate those types of limits, we can finally talk about some special theorems regarding limits before we finally talk about continuity.